Hello friends, I hope you all are doing good. So in this lecture, I'll be discussing the seventh question of my data science end semester paper. So the question says, consider a tiny dataset where some types of error that could occur. Can you find any problems in this dataset? If any, explain each of them. So basically, we have given a table here of a customer ID, its PIN code, its gender, its income, its age, and its marital status, and the transaction. So basically, we have to figure out that if we can see any error, we have to write that error and explain that error. So let's start. We first discuss attribute by attribute some of the problems that have found their way into dataset. So firstly, seeing the customer ID column, which seems to be fine because every customer has a unique ID. Now, moving on to the PIN code. Here we are all expecting the customers in dataset to have the usual 5 numeral US zip code. The customer 1002 is okay because the customer 1002 has a zip code of J2S 7K7, unusual value, maybe an error and toss it out. Not all countries use the same zip code format. So we all basically expecting a 5 digit numerical pin code, but not every country has a 5 digit numerical pin code. Some has 6 digit, 5 digit containing both numbers and letters. So actually this is a zip code of Saint Hyacinthe, Quebec, Canada. So basically, it's a pin code of a city, Saint Hyacinthe, in the Quebec state of Canada. So probably represents the real data from a real customer. The customer 1003 seems okay. The for customer 1004, we are unaware of any countries that have a 4 digit zip code, such as 6260 indicated here. So this must be an error, right? Probably not. Zip codes for the New England states begin with the numeral 0 unless the zip code field is defined to be the character text and the not numeric. The software will probably chop off leading the 0, which is apparently what happened here. The zip code is probably 06260, which refers to stores Connecticut. Gender attribute contains a missing value for customer 1003, which is a data imputation technique to fill the missing value. Now, we'll be seeing the income field is measuring annual gross income, has three potentially anonymous values. Customer 1003 income of around 10 lakh dollar per year, possibly especially when considering the customer zip code 90210 Beverly Hills. This value of income is nevertheless an outlier, an extreme data value. Certain statistical and data mining modeling techniques do not function smoothly in the presence of outliers. Poverty is one thing, but it is rare to find an income that is negative, as our poor customer 1004 has. Customer 1004's report income of minus $40,000 lies beyond the field bound for income and therefore must be an error. It is unclear how this error crept, with perhaps the most likely explanation being that the negative sign is a stray data entry error. However, we cannot be sure and should approach this value cautiously, attempting to communicate with the database manager most familiar with the dataset history. For customer 1005, income of dollar 99,999 dollars. Perhaps it may in fact be valid, but it for all other incomes are rounded to the nearest 50,000, nearest 5,000. Why the precision with customer 1005? Guys, just wait for a second. So basically, you can see that the all the incomes are basically round off, but this 99,999 dollars is not round off. So basically, it may create an error. Often in legacy databases, certain specified values are meant to be codes for anomalous entries, such as missing values. Perhaps 99,999 was coded in an old database to mean missing. Finally, our we clear as to which unit of measure the income variable is measured. In database often get merged sometimes without bothering to check whether such merges are entirely appropriating for all fields. For example, it is quite possible that customer 1002 with the Canadian zip code has income measured in Canadian dollars, not US dollars, because the one US dollar and one Canadian dollar differ in the Indian currency. The age field also has a couple of problems, although the other customers have numerical values for age. Customer 1001 age of C probably reflects an earlier categorization of this man's age into a bin labeled C. So basically, we have converted the numerical data to categorical data. The data mining software will definitely not like this categorical value in otherwise numerical field, and we will have to resolve this problem somehow. Customers 1004 age 0. Perhaps there is a newborn male living in stores in the Connecticut area who has made a transaction of $1,000 more likely. The age of this person is probably missing and was coded as 0 to indicate this or some other anomalous condition. Example, to refuse to provide the age information. Of course, keeping an age field in a database is a minefield in itself, since the passage of time will quickly make the field values absolute and misleading. It's better to keep data type fields such as birth date in a database, since these are constant and may be transformed into ages when needed. The marital status field seems fine, right? Maybe not. The problem lies in the meaning behind these symbols. We all think we know what the symbol mean, but are sometimes surprised. For example, cold water in a restroom in Montreal and turn on the faucet mark C, since the C stands for short, which is French for hot. Thus, there is also the problem of ambiguity. In table, above table, does the S of customer 1003 and 1000 stand for single or separated? So basically, all this single digit letter can create confusion. So it's better to write the proper full form like the marital status is married, widow, single, separated, or divorced. This might create confusion. The transaction amount seems satisfactory as long as we are confident that we know that the unit of measurement is being used and that all records are transacted in this unit. So guys, this is all we have figured from the table: the missing values, the outliers, the negative income, the PIN code, the marital status, and rest all. So guys, this is all from the video. Thanks for watching. Bye.